Containerized Geant4 completely eliminates the need of installing Geant4 in one's own computer. Including a universal Geant4 application further eliminates the need of C++ coding. Such a container is extremely beginner-friendly. Ever since I created it, I used it to teach undergraduate students and professors how to get started with Geant4 within a few hours because it takes care of all the programming details and the end user can focus on simulation itself. Today, I'd like to share with you some exciting improvements on the containerized Geant4. If you are not familiar with the concept of container, please click the link at the top right corner to watch Get Started with a Linux Container and Containerized Geant4 in my container playlist before continue. If you already have the Docker desktop up and running, click the search box. Search for Physino Geant4 instead of Physino Gears for a more up-to-date Geant4 container. Click Pull to download it, or Run to download and run it. Expand the optional settings in the Run dialog. This is critical, please don't skip. Specify two host port numbers. A simple choice would be to just copy the numbers shown on the right side. This is useful to display your analysis figures on the browser in your host operating system. We'll get into that near the end of this tutorial. In the container, I assume that your simulation will be performed in the folder root geant4, so type it in the container path. You can map a random folder in your host operating system to root geant4 in the container so that your work will be saved in that folder even if the container is deleted. Click the three dots to bring up a file browser to select a folder in your host operating system. As an example, I created a folder called G4 in my users folder and select it. If it looks good to you, click Run to create a container from the Physino Geant4 image with these port configurations and folder mappings between the host and the container. Once the container is up and running, you should be able to see the randomly generated container name, the image it is created from, the port mapping, the status, and some log message, which indicates the Geant4 version and the container operating system. This can be used to confirm that you are using the latest official Geant4 binary release. On AlmaLinux, to control your container, you need to switch to the exec tab for interactive shell. Follow the instruction to switch to the exec tab, where you will be instructed to type tmux-u for better shell. A shell is just a funny name of a user interface. Press return to execute the command. You should be able to see a more informative command line prompt, including your username in the container, which is root, the administrator, the container operating system, and your current working folder, Geant4. The word New on the top bar can be clicked to create more tabs, and the Close button can be used to close them. Click on the empty space in the top bar will split the window to two to use the space more efficiently. This working environment is provided by the command tmux with some configurations customized to this container. There are many tutorials about tmux out there. Feel free to learn more by yourself. For now, let's just go back to our first tab and type history and return. In the normal case, this command is used to list old commands you used before. You just got into this container. Of course, there shouldn't be any old command. It is me who saved some useful commands in the shell history to demonstrate the usage of the container and to save your some typing in the command line. Press the up arrow key repeatedly to bring the old commands one by one back to your shell prompt until you get this one, which will download some files from github.com to your Geant4 folder. If you go too far up, use the down arrow key to come back. Press return to run this command. After downloading is finished, type letter L and return. To bring up a file browser called LF in your shell, where you can see a bunch of files and folders appears in your Geant4 folder. Press Q to return to a shell prompt. Now use the up arrow key again to bring this command back to a shell prompt. Press return to download 12 Geant4 datasets from the Geant4 website to your Geant4 folder. Once the downloading is finished, press the letter L and return. To open the file browser again, use the down arrow key to select the data folder. Press Enter or the right arrow to get into the folder. And you should be able to see 12 Geant4 datasets we just downloaded. Use the up or down arrow to select different folders and use the left arrow to go back to the parent folder. Two tiny Geant4 applications, Gears and Mingle, are included in the container. They allow you to write your detector definition in plain text format. Mingle is the simpler one, which has only 81 lines of C++ coding, including empty lines, perfect for learning the basics of Geant4. You can directly type Mingle or use your up arrow key to bring the command to your prompt. Press Enter to run the command, and your first Geant4 application is up and running. Inside your Geant4 interactive session, you can use the ls command to list available Geant4 macro commands, which are grouped as folders. Note that they're not really folders in your hard disk. They are just a convenient way to organize a huge amount of Geant4 macro commands. You can use cd to get into individual command folders, and use the help command to print out detailed information about individual macro commands, such as create HTML, which is used to generate HTML files for all the commands and folders we can see here in the terminal using the ls and the cd commands. Let's try it out. Press return to run it, and exit to quit the Geant4 interactive session to come back to the Linux shell. Use L to list files in the Geant4 folder. In addition to the existing folders and the files, you should be able to see all the HTML files you just created inside the Geant4 interactive session. I didn't include a web browser in the container to keep its size small. But remember, the Geant4 folder in your container is mapped to a folder in your host operating system. Switch to the Bind Mounts tab and click the source folder name to open it in your host operating system's file browser. Double-click on the first HTML file to open it in your host operating system's web browser, where you can use the mouse to click around to learn about Geant4 macro commands. In order to keep your Geant4 folder tidy, you can create a new folder called Menu and drag all the generated HTML files into it. There, nice and clean. Go back to our Docker desktop, hold Control key, and then press R to refresh the file browser in the container. And you should be able to see the manual folder created in your host operating system's file browser. This is not a surprise, as we know they are mapped to each other. The compiled Mingo executable is included in the container, but its source code is not. Bring back this line of command to download the Mingo source code from the internet. The same way works for the Gears source code. Use L to list files in the Geant4 folder. Now we have the datasets folder, the manual folder, and the two Geant4 application folders. In the Mingo folder, you should be able to find a file called detector.tg. Press Enter to open it. In a text editor called Micro, where your mouse is enabled, and you can use the editor as you use a notepad on Windows or TextEdit on Mac. In this file, an experimental hall filled with air is defined as a 10 by 10 by 10 cubic meter box. A cylindric stainless steel vacuum chamber is placed in the experimental hall, and the cesium iodide scintillation detector is placed inside the vacuum chamber. Click the link at the top right corner to learn more about how to define your own detector geometry. To use this detector definition file for your simulation, you need to place a bunch of Geant4 macro commands into another text file. Let's call it run.mac, where we can shoot 10,000 2.6 MeV gamma rays to our cesium iodide detector and save the energy deposition in our detector in a variable called E. To use this file, you just need to put it behind the Mingo command and press return. By the end of the simulation, an output file called scoring.root will be created. We can use the Python library uproot to open this file and get the energy deposition in the cesium iodide detector as an array, and draw the energy deposition in a histogram with 100 bins. The matplotlib included in the container will serve the generated histogram in a web server. You can click the port listed here to show the histogram in your host operating system's web browser. The figure is interactive. For example, you can place your mouse to a specific point on the figure to read out its coordinates. To avoid typing all the analysis Python codes by hand, I saved them in a file called drawe.py. It is executable. Press return when you select it in the LF file browser to run it, and click the port link to open the result in your host operating system's web browser. When you're done, go back to your Docker desktop, hold Control, press C to quit from Python. You can stop or even delete this container when you finish your simulation. You won't lose your simulation setups and results as they are saved in a mapped folder in your host operating system. However, a container uses very small resources on your host computer. It's very safe to keep it running if you will. To restart your container, just go to the containers list, find it, click the Start button to restart it. The port and the folder mapping should still be there. There's no need to reconfigure your container. If you cannot see the exec tab, Just click on the empty space to bring it up. To summarize, the Physino Geant4 container image includes the newest official Geant4 binary release in the AlmaLinux. 2 end-user-friendly Geant4 applications that requires no C++ experience to use. 3 modern terminal programs with mouse support to provide a user-friendly command line user interface, and Python-based data analysis libraries. It runs in 3 major operating systems with consistent user experience. It enables seamless data sharing between the host operating system and the container with mapped folders and ports. Enjoying it?